Okay. So guys, a standard definition of cloud computing, which says that cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configuration computing resources, such as networks, servers, storage, application, and services that can be rapidly provisionized and released with minimum management effort or service provider interaction. So that is a long definition that is given by the NIST. So in the short form, or in the understandable form, you can say that you can say that a cloud is ubiquitous. Ubiquitous means it is available anywhere, anytime. Means whenever you have a minimal system, a minimal computing node, okay, it doesn't require like any high-end system or anything, any specific configurable system. You just need a computing node, and if it have a internet connection, you are able to connect with the high-end servers into the cloud computing. Convenient. Convenient means any kind of device, whether it's a thin client, it's a big client, it's a workstation, it's a mobile device, or you are in your office or home or anywhere, you are able to connect with them. On demand network access means on the demand, whenever a demand arises over the network, you are able to connect with them. Another point, or the most important point, the shared pool of configuration computing resources means a cloud computing have a large computing resources. Okay, so what could be a computing resources? A computing resources mainly known as central processing units, that is CPU, okay, storage devices, okay, also known as hard drives, and networking devices, and then services and applications. Okay, so mainly CPU, storage, and networking, they create the part of an infrastructure. They create a part of an infrastructure. So you can correlate it with that. Like whenever you go into the market to purchase any personal computer, a laptop, or a mobile device, what you see what kind of CPU it possesses, what is the capacity of storage, and on which network it is able to communicate. Okay, so these all kind of services, now you are able to purchase over the network, using the network by cloud computing, and all of these are available to you over the network with minimal human interaction, or you can say with uh, no human interaction, or you can even say without any human interaction. You are able to perform a computation, or able to use a storage service, able to use a database service, able to perform web application or any kind of services using the cloud computing. So guys, you are getting my point? Okay, I hope you people are getting my point. So you have seen that there is a difference between a traditional computers and the cloud computers, or a cloud computing. Okay, so in few slides we will see the characteristics of the cloud. Then we will be in a better position to discuss the difference between a traditional computing device and a cloud computing model. Okay, so the first characteristics, although it is covered in the definition, but the first characteristic is broad network access. So broad network access means all the network protocols that has been laid down in TCP/IP or ISO models are also applicable here. Means whenever you are trying to connect with the cloud, or the machine that you have provisioned in the cloud is trying to connect with some other machine or device in the network, they are all able to perform communications seamlessly using the standard protocols. Okay. The next point is that you are able to connect with the cloud computing or with the data centers using any kind of mobile device, workstation, or any kind of thin or thick client. Okay, so that defined the broad network access. It doesn't there is no kind of boundary that you are going to connect with the homogeneous device or a heterogeneous device. You are able to or free to connect with any kind of device to the cloud computing. The next point is resource pooling. Okay, so what is resource pooling? As you know that whenever you have a personal computer, whenever you have a personal computer, you whenever you have a personal computer, the personal computer have some or other kind of configuration, and that configuration is a rigid configuration. Why I'm saying it rigid configuration? Like, let's say you have purchased a mobile device, and that particular mobile device is a, you can say, latest in the market. So it have a Snapdragon 850C chipset, some 6 or 8 or 12 GB of RAM, and similarly 128 or 256 GB of memory space. Whether it is possible that you can change its configuration within a fraction of a time, is it possible? No, you can replace your mobile device, or you have purchased a latest laptop or a desktop or even high-end workstation. Whether it is possible to increase or decrease its configuration? No. However, it is possible in the cloud computing. What you do, you what the cloud service providers do, they purchase a huge amount of computing resources and make a pool of resources. Once they have made the pool of resources, after that they implement virtualization technologies. Over the virtualization technology, they specifically categorize the devices, the storage devices, the CPU devices, the networking devices, the routing devices, or other kind of devices. And now they are free to provision those services to number of clients, starting from C1 to CN. Any client, they are free to give all those services. Okay. And also, since since a physical device underlying the virtualization technology, a single device is used, and over it a multiple clients are using the single hardware resource. That is why it is known as the multiple client environment. Means the provider's cloud computing resources are first pooled together, then you use the virtualization technology, then after that those resources are distributed in multiple clients, or you can even say the multi-tenant. Cloud resources are pooled to serve multiple consumers, different resources dynamically assigned according to the demand of the customer, and the pooling together of the resources builds the economy of scale. So the most important point in the cloud computing is that it's all about the economy of scale. Means whenever you are going to purchase any particular item in the market, so if you are going to a retail distributor, you, let's say, you are getting it in 100 rupees, but when you are going to purchase an item from a wholesale distributor, definitely you will get that particular item in some lesser amount, let's say 19 or 80. So if the economy of the scale is very large, you get the item economically. So that's what happened in the cloud computing. If you individually purchase, the computing resources that may be expensive. But if you are going to purchase from a cloud service provider, because a cloud service provider can negotiate better with the hardware distributors, it provide you the same service on very lesser amount. Okay, and also there is other concepts of purchase versus rent. Okay, when you purchase you pay more, when you rent you just pay the amount equivalent to the time you are using that service. Then other characteristics are on-demand self-service, means whenever you have a demand, you have provisioned the service and you are using those service. Rapid elasticity, that is a very important point in the cloud computing, rapid elasticity. A rapid elasticity means whenever a demand arises, the cloud will automatically increase the server configuration, you can say, or increase, it's quickly scale up the uh, overall the capacity of the system. Okay, and whenever there is a low demand, okay, it will scale down. So that kind of thing is not possible in a traditional computing now. A traditional computing environment is a resident environment. What would be the configuration of the traditional computing environment? It should be with it, whether you are using that system to up to the 100% or up to the 10%. However, in the cloud computing environment, you are free to do so. Okay, whenever you required a very large system, okay, a very large capacity system, you will simply scale up your provisions, and whenever you required a least amount of systems or a least configuration of the system, you simply scale down the configuration. Then finally, the pay as per you go model, or also known as the measured service, means you will pay for the service that you are using for the amount of the time. So in most of the time, the cloud computing have most of the time the cloud computing have uh, like you have provisioned a virtual machine. Okay, and if that virtual machine have a cost implication of, let's say, 0.3 cents, okay, per hour, on the per hour basis, and let's say you are going to use uh, that machine for 1 hour or 2 hour. So just you will multiply that per hour cost with the number of hour of usage. You will get the total amount that you have to pay for provisioning a virtual machine. Okay, so that is the important characteristic of the cloud. So by analyzing the cloud characteristic, you may able to understand what is the difference between a traditional computing environment and a cloud computing. So the first point is the amount of flexibility. You are not getting any kind of flexibility in a traditional environment. However, in the cloud computing, you have a degree of freedom, of flexibility. You can configure your devices. You can choose. Uh, you can choose from a marketplace. You can choose from a marketplace like what kind of server you want, what kind of configuration your server should have. Okay, so let's say one day you want a server, high-end server like octa-core processor, and other day you want just a single core processor. So you can do that, but in the traditional environment that is not possible. Okay, so let's move forward. So those are the essential characteristics. Other common other common characteristics are massive scale. So whenever you heard about the cloud computing, it have the massive scale. Okay, it have the massive scale. Massive scale means a large pool of resources that are configurable and that could be easily provisioned to the multiple clients. Then resilient computing. Resilient computing means even if some of the services is not performing up to the agreement of the SLA, means service level uh, agreement that you have done with your client, but still it will perform in a graceful manner. Okay. Then homogeneity of the service. You can provide the services to the clients, okay, over the network protocol that is already stabilized in the TCP/IP model or in the ISO models. Then geographical distribution of the services. As you know, the cloud computing services are geographically distributed in multiple locations. It could be, uh, if I will demonstrate you that thing, that is known as zones. They are known as zones. Okay, so AWS service, if just if you are going to see the AWS service, so that AWS service is distributed in North America, then it is distributed also in South Africa, then Asia Pacific region, then South Asia region, or you can say in the entire world. So that is the geographical distribution of data centers. Okay, so that particular distribution have few benefits, also it have few loss that we will discuss in the later part of this presentation. Then the virtualization technology. So the by virtualization technology, it's provide you the multi-tenancy, and also it increase the overall utilization of the physical resources, and at the same time virtualization brings many security and privacy concerns. Okay, the entire uh, infrastructure is a service oriented over based over service oriented technology. Okay, then finally it offer you low cost softwares, because there is no need to purchase the licensed software. Cloud will give you those software, and the license is taken on behalf of you. Okay, so this is, you can say, the rented economy versus the purchased economy. When you are purchasing a particular item, you have to pay more, and when you are renting a particular software, you have to pay less. Okay, so that's what's happened, and in this way they offer you the low cost software. Although I am going to discuss about the security issues in the cloud computing, but I at the same time I want to add that most of the cloud service providers provide provide better security than what you are able to achieve on your personal devices. Okay.
Uh, Hi, sir. I think your audio is trailed off.
Actually, uh, there is some issue, like I am not able to go on the next slide.
Okay.
uh, I'm not able to switch off the annotations. Is there is any issue?
No, sir. You have entire presenter rights from my side.
Okay. Can you
You
tell me
can can you refresh, or maybe you can try. If it's not happening, sir, then I think you can log in, log out once.
Sir, come out of the presentation mode, sir, in the slides.
Okay. Yeah. No, it is okay.
Okay, sir. Thanks.
Thank you. Thank you so much.
Okay. So the next thing is the service models. Okay. So guys, I hope you are able to understand between the traditional computing model and the cloud computing. Okay. Uh, so after that, in the cloud computing model, we will discuss about the service model. So mainly the service models are categorized into three parts. The first one is infrastructure as a service, another one is platform as a service, and the last one is the software as the service. Okay, so the infrastructure as the service, in that the physical hardware's operating system is managed by the cloud vendor. Okay, then in the platform as a service, along with the infrastructure, the runtime environment and the middleware is also managed by the cloud service provider. I am just writing it as a CSP, means cloud service provider, because many of the web letter on presentation may be used as a CSP, okay, cloud service provider. And as a software as a service, all the stack is entirely managed by the cloud service provider. You are just using those services. Okay. So the first one is the infrastructure, as the name suggests. So you are compare the infrastructure, or you can create an analogy of infrastructure, that you are going to buy a new system. You are going to buy a new system. So if you are going to buy a new system, what you see? You see the CPU configuration, the storage system, and the operating system. Okay, the three things that you see, and once you are convinced with that, you purchase that system. In the same way, you have a marketplace in the AWS system, or in the Azure, or you can Google, or any of the cloud service providers. You have a marketplace, and it is categorized in either the free service or the paid service. Okay, and it have different kind of configuration, with a single core system, multiple core system, high-end system, and even multiple kind of main memory, auxiliary memories. Okay, and also the amount of networking you want to use. Okay, you want to use a very fast networking or slow networking, or thousands of input output operations, or tens of thousands of input out of operation. So depending of uses, you provision the service, you purchase a server over the cloud system. So when you purchase a server over the cloud system, that is known as the infrastructure as a service. Because you are purchasing the infrastructure. The next thing is that once you have purchased the infrastructure, it's a bare metal, it's a bare hardware, what you will use with those hardware. So the next thing is that either you will install the middleware and the runtime environment to running your applications, okay, to managing your data. For that purpose, you will install your middleware. Like if you want to run a Java program, okay, so for that purpose, you will execute your JVM machine over this infrastructure, and then execute the Java programs. Okay, so that will be come into the platform as a service. So either you can directly use a platform as a service. There is no need to configure or anything. The entire machine is pre-configured, and you will just come and perform the coding exercise, uh, or you will just develop the application and test those applications rather than configuring the machine. So platform as a service provide those kind of services, or support those kind of services. Then finally, it come to the software as a service. So in the software as a service, what happens? You are directly using a software. Let's say here I am using the Office application over the Microsoft Azure. Okay, so I am directly using the Office application over the Microsoft. It is not installed over my system. I am directly just using it. Okay, so everything, the system configuration, the amount of storage, the memory, and everything, the runtime environment is provided by the Microsoft. My system is just presenting just presenting those, you can say, just presenting the slides. It is not executing on my system. The entire execution is happen over the Microsoft system. So that is what happened in the software as a service. If you want to use a video streaming service like YouTube, what you are using? You're just uploading your videos to the YouTube servers, and with the help of browser, you will stream your data. So whether your system is executing or rendering those video services, not. Your system is doing nothing. Your system is just representing that information. The entire execution and everything happen over the Microsoft servers or the Google servers. That is what categorized as a software as a service. The next thing in the software model, I had just categorized so that you are able to understand that, okay, in a different kind of picture. So this is infrastructure. This entire thing is the infrastructure. Okay. Then these are the platform that falls into the category of platform as a service. Then these are the applications, and it falls into the category of application. Okay, so you are able to see the compute means CPU, the block storage means the, you can say, the main memory and the auxiliary memory. Then finally all the block storage means just the hard drives. But when you are provisioning an infrastructure, you are provisioning both the things. Like it provide you the flexibility to configure your main memory, and at the same time the amount of storage you want to store your auxiliary memory also, and then the network services. Then in the platform as a service, the databases and the identity info environment and the object storage, all kind of these things provided as a platform as a service. Like whenever you are going to discuss any application, if you are going to use any application, at that time you will use a web server. So if you need a web server, your web server will run on a system. The web server will communicate with a database server, and then only your application will launch. Okay, that is why you need such platforms to run your application. Finally, in the software as a service, whether you are going to launch a chat server, if you are going to launch a financial service, you are going to launch a collaboration like Google Calendars or something. So if it is a fully baked service, you are not going to write any kind of code or performing any kind of uh, configuration or something like that. You are just using those applications. Okay, so that kind of thing falls into the category of software as a service. Okay, and if you are free, if you want some kind of degree of freedom or flexibility, and you are going to develop your idea over it, that comes into the category of platform as a service. Just provide you all the environment, all the configuring environment, platform, services, everything. You have your idea, you have your concept, you go there and you implement it and then launch your service. Okay, so that falls into the platform. And for supporting a platform, for hosting your service, there is also support of infrastructure. Okay, so that's all in the service model. The next thing is the deployment model. So we have discussed the characteristics of the cloud computing. Then we have discussed the service model of the cloud computing. Another important thing in cloud computing is the deployment model. So deployment model says that a cloud could be categorized into mainly 3 categories, and sometime it's a hybrid cloud. Okay. So there is a public cloud. So if you want to see a public cloud, so all these cloud services all these cloud services whether it's a AWS cloud, okay, or a Google cloud or IBM cloud. So I'm showing the websites of AWS cloud, Google cloud, then MS Azure. Okay. So in the evening we will use this particular AWS cloud, okay, to see, to demonstrate you to how you can perform an execution over the cloud computing. So these are all falls into the category of public cloud. The reason being, anyone able to use these services, any person are allowed to use these services. That's why it falls into the category of public cloud. Okay. Then is a private cloud. So private clouds mainly dedicated to some particular organization or some particular company. So you can say that if there is some large organization which is geographically distributed in multiple locations around the globe, and it's want to use its own personal cloud, its own personal cloud computing. The reason being that a personal cloud computing or a private cloud computing is more secure than a public cloud environment. It's the assumption that people assume that since it's a private, only the employees or the vendors or the clients of that particular organization is allowed to enter in that cloud computing environment. So that is more secure than the public cloud. And also, since the data and the other company's assets or within the premises of that public cloud, that is why it is considered secure than the public cloud environment. Then there is a community cloud. So the community cloud is the cloud where multiple similar kind of organizations make an agreement, make an MOU, and create a cloud. So those kind of clouds known as community cloud. So for an example, take that like there are multiple institute, let's say for example IITs. So there are 23 IITs in the country, and if they want to collaborate over the cloud, they are possibly able to build a cloud which cater the services of the IIT. So that is a kind of community, and they have made their own community cloud. Then finally, it's a hybrid cloud. So hybrid cloud concept is that if there is any kind of mixture of public, private, or community cloud, so they built a hybrid kind of cloud. Okay, so these are the deployment model. So whenever you are using a cloud computing services that is guys, please mute your mic.
I'm trying from my side, so even it's not happening. Requesting everybody, please mute your mics. I have muted everyone from my side.
Okay, so that is the deployment model, in which either the cloud is deployed in a public environment where any general public is free to use the services of the cloud. So there are multiple public cloud vendors like Google Cloud Compute, Microsoft Azure, Amazon Web Services, and IBM Blue, and etc. etc. You can say even 50 or 70 major prominent cloud service providers in the
Sorry to
market.
interrupt, Professor Malik. Is this
Yes.
disturbance coming from your end, or is it?
No, ma'am. Like some of the students has opened their mic. That's why we are getting this interest.
I have muted everybody from my end, and I just requesting everybody please mute your mics. I am muting everyone, but I think somebody is consistently switching on their mic.
It's probably someone joining from their mobile.
No, I think I see some Puneet name. It is coming. This is Sri Krishna here. I'm a participant. So I'm saying keep on saying Puneet.
Puneet, please mute your mic because I am consistently muting everybody, and yet your mic is getting on. I'm muting all participants. If you are unable to keep your mic mute, then we'll have to ask you to leave, creating a lot of disturbance. I think it's better, sir, now.
Yeah.
Thank you so much, Sri Krishna. Sir, thank you, Melissa. Please continue.
Okay, so that is what in the deployment model. Okay, moving ahead. So that is what I have written in the bubbles that I have discussed. The cloud infrastructure is provisioned exclusive use for any single organization, that is falls into the category of private cloud. And the cloud infrastructure is provisioned and open to use by the general public, so that falls into the category of public cloud. Then the cloud infrastructure, if it is a composition of two or more distinct cloud infrastructure like public, community, or private, that falls into the category of hybrid cloud. And if the multiple organizations collaborate with each other and exclusively making some kind of cloud, that falls into the category of community cloud. Okay. Okay, guys. So till now, that is the introduction part of the cloud computing. So I have given the introduction that's just because all of the participants on the same page. At least they have some understanding of cloud computing. Okay, at least the term coined in their mind, the term of cloud come into their mind. Okay, so although I know most of you, if never provisioned any kind of virtual machine over the AWS cloud or Azure or Google cloud, definitely you are not able to correlate with that. Okay, you are not able to bond with that, but at least you have some understanding. Means if there is a traditional computing environment, that is your personal system, your laptops, and other things that are the rigid system, it is not possible you are dynamically increase or decrease the configuration. Guys, again, someone has unmuted their mic.
I request all those who have joined from mobile phones to please check if your mics are on mute. Because for the mute all option, it is only showing those who have joined from PC. Please ensure your mics are on mute. The session getting disrupted again and again because of this it's not right.
Guys, it's a very genuine request. If you people are disturbing the session again and again. So it will be a loss at your end. Okay, so don't do that. Also, many of you may lose your interest also in the entire topic, and also even this as a speaker, uh, it's like very much disturbance in that. Okay, I am also maybe losing the interest if you are doing again and again the same thing. So it is don't repeat it, don't do it. Okay, just try to focus on the points and on the topic. Okay, guys, so till that point we have discussed most of the introduction part of the cloud computing. Okay, where we have seen what is the difference between a traditional computing environment and a cloud computing environment, and what kind of service a a cloud computing environment offers to its client, and what kind of service model is there: infrastructure as a service, platform as a service, software as a service, then their deployment model, the definition of cloud. Okay, so now uh, we are able to understand that there are very many benefits of cloud when we are using the cloud computing over a traditional computing environment. Or you can even say that, okay, uh, the cloud computing is known as the utility service. Okay, so what is utility service? As a utility service means like electricity or water supply, they falls into the category of utility service. Means electricity is flowing into your house, and whenever you are switch on your any electric device, it just start functioning. It's just start functioning. In the same way, uh, in the same way, when the cloud computing has launched, the vision is that the computing services are offered as a utility service. So whenever a system which is able to understand, which is able to understand the signals of internet, it is able to use the compute, it is able to use the infrastructure of the cloud. That is what the vision of cloud computing. Okay, but once we have reached to a position where the cloud computing has launched and it is open to use to the public or general public, and multiple organizations are also frequently using the cloud computing services. Okay, so it's a, you can say it's a breeding ground, it's a breeding ground for the hackers and other adversaries. Why? Because they are seeing there are a lot of people and huge amount of data at a one location. If there is a lot of people and huge amount of data and computation over at a one location, it's attracting to the hackers, adversaries, and other kind of illegitimate people at a one place, so that they can steal the sensitive information and sell in the market. Okay, and that is why a multiple kind of security issues arises in the cloud. So we will see those issues one by one. The first thing is the loss of control. So what is mean by loss of control? So in the cloud computing, what you are doing, you are outsourcing your work to some other people. You are outsourcing your work to some other place, to some other people, so that they store your data, they perform computation over your data, and you are just considered that you only want your result, that you only want your final output. So now the data and the computation, or you can say the trade secrets, okay, that should be resided in your premises, now it is at the third party cloud servers. What is the benefit over there? The benefit is that there is no need to maintain any high end IT infrastructure. There is no need to recruit any critical human. requirement, because there is no IT, so there is no need of human, no need of human resources to maintain those IT. Okay, so in this way you have reduces your capital, and operational expenditures. Okay, but you have physically loses control over data and your computation, and that is the root cause in many clients of the cloud. Okay, what will happen to the data, because it is at the third party premises, and that is why data confidentiality, integrity and availability issue arises. Okay, so I hope you know about the confidentiality and the integrity. Means if there is a breach to confidentiality, means if someone is secretly seeing your data without authorized permission, that falls into the category of confidentiality. If someone has unauthorizedly altered your data, okay, or misusing your data, or some deleted your some part of the data, so that falls into the category of integrity. And the availability issues, that the data is your in the third party premises. If something cloud outage happen, means a service has been blocked, a service has been terminated, okay, a outage happen, a blockage has been happen, now you are not able to use your service, you are not able to access your data, you are not able to perform computation your data. So at that time this availability issue also arises. Clear to everyone? The next thing, lack of transparency. So the lack of transparency arises because the operation happens inside the cloud computing, inside the cloud computing environment, is not visible to the client. Okay, not visible to the client means whenever you have outsources your data and computation to the cloud system, you are just giving instruction to the cloud to perform computation over the data, to perform analytics over the data, to perform storage of data, to transmission of the data. Okay, so such kind of instruction you are giving, but how the cloud is performing those kind of instructions, you don't know. Further, to increase the reliability of the data, what you have given, you have told to the client service provider, just replicate my data to multiple location. Once you have performed the replication of data to multiple location, it may happen that there is a synchronization issue arises. Means the replication happen, means if you have performed an update or insert operation in any one of the location, that synchronously updated to all the location. Then after some time what you have decided, let's delete that data, the data is obsolete, of no use, but still the data is sensitive in nature, so you have instructed the cloud, just delete it. So it have deleted to few location, but it have maintained some copy that it will sell later on in the secondary market. Okay, so that will be a huge issue, that will be a lack of transparency, a trust deficit between the cloud service providers and the cloud service users. Further, most of the cloud service providers use some or other kind of security controls to avoid the adversaries, to avoid the confidentiality and integrity breach. Okay, but those security controls are not discussed with the cloud users. Okay, because they treated it as the trade secrets. Okay, so let's say the two vendors, that is Amazon AWS Amazon, and the other vendor is Google. Okay, and if you see the incidence of a cloud breach, okay, happens in 2020 or 2019, there is a more number of breach happen in the Amazon Web Services than the Google Cloud Computing. Okay, I am just using these statements to convey my concept. Okay, don't take it as as a correct news. Okay, so as a cloud user, when you are going to use the cloud computing, you have compared those incidents, and by comparing those incidents, what you have found out that Google is more reliable than the Amazon. Okay, but if Google is reveal those secrets to their clients that I am using these kind of security controls to secure your data or the computation. So maybe Amazon will replicate those security controls in their data centers. And in this way, the trade secret will reveal. And that is why the cloud service providers don't discuss these things with their client. Okay, so here there is a lack of transparency, lack of trust between the cloud service providers and the cloud users. Okay, guys. The next thing, the multi-tenancy issue. So as we have already discussed that the cloud service provider, have a pool of configurable resources. Once they have pool of configuration resources, so another point I want to add here, what is the pool of configuration resources? Let's say you have a commodity device, you can say a PC, a personal computer, a desktop, fall into the category of commodity device. A data center may have hundreds or thousands of those commodity devices. Okay, so what they do, they put all them in a rack servers, okay, and make a huge pool. That pool has been made, but how they will offer those service to any kind of user? So that is why they install a virtualization, a VMware over a virtualization environment over these configurable resources. Once the virtualization is installed over it, now they are able to outsource those resources to multiple clients. Okay, so in this way they reduce the cost, because at a single physical hardware, multiple virtual machines could be provisioned. Okay, and now on a single hardware, multiple clients are using. If on a single hardware, multiple clients are co-resizing or executing itself, so there is an opportunity for any illegitimate client to access or sneak peek the data of other clients. Okay, so it creates the multi-tenancy, creates the issue of security and privacy. Later, the virtualization environment, data belonging to different customers may be placed on the same physical machine by certain resource allocation policy. Okay, and adversary who may also be a legitimate cloud customer may exploit the co-residence issue. Okay, they may exploit a side channel attack in the main memory to access those data. If that will happen, so at that time, data confidentiality, integrity, flooding attack, availability, and accountability issue arises. And these issues are reported in many literatures. Okay. Next is massive pool of resources. Massive pool of resources brings massive concentration of risk, since the scale or the computational breach, a single computational breach could be significantly large, because using those virtualization technology, you are now providing the services to hundreds or thousands of the clients. And if a single breach happen, adversary might steal the information of hundreds or thousands of customers, and that could be a significantly large. Okay, So concentration of users represents the concentration of threats, and ultimately we are outsourcing our data and computation to a third party cloud server to performing the computation on our behalf. Okay, but it is not like as a company we are also outsourcing the responsibility. Okay, so let this is the cloud service provider. Okay, and this is the cloud service user. After that, there are n number of end clients. N number of end clients. So these clients are using the services of this company. If this cloud service provider has restricted the availability of data for this company, it will impact all these clients. It will impact all these clients. If a confidentiality breach happen in this cloud service provider, means it has steal some or part of the data of this cloud service user. That will mean that it have steal the data of these individual clients. Okay, so that is what this entire thing disperse over a large number of clients. Okay, next, that is the traditional security methods are irrelevant. Why I'm saying the traditional security methods are irrelevant? Okay, why it is like written in the literatures that traditional irrelevant? The reason is, let's say as traditional security method, you are using an encryption technique to encrypt the data. Okay, so most of the time whenever we want to secure a data set, we simply encrypt those data. We have encrypted the data at our system and then outsource that data to the cloud, and the cloud will rest that data in their storage system. The point here is, when you are performing such kind of thing and you have stored the data in the cloud system, okay, that may secure your data. But let's say after some time a request has been arised to perform some kind of computation over that data. So as you know, once you have encrypted a data set, once you have encrypted uh,
Sir, we
yeah,
lost.
just a minute. Yeah, just a minute.
Professor
So
Male, we had a tea break before the next session. So will we be
yeah,
continuing or will we be giving
yeah,
a break?
yeah. We can give a break. Okay, and we will
Okay.
again meet at 12:30.
I think we no, sir. The next session is at 12, or would you
Okay.
prefer 12:30?
So if if student will be available at that time, so we can reduce the break, and if they want
Yeah.
for 1 hour, then we will meet at 12:30.
I think what we can do is, sir, we can continue now for another 15 minutes. We can give a 15
Okay.
minutes break, and
Okay.
then we can start at 12 and then till 1 o'clock, right?
Uh, okay. Let's start at 12:15. Okay. At that time, I will also get some break. Okay.
Sure, sir. Sure, sir. As per
Yeah.
your convenience.
Yes. So guys, if you encrypt a data set using some or other kind of encryption algorithms, you are able to secure the data. But since the cloud computing is providing the cloud computing is provide storage service and the computer service at the same time. So if a request has arisen to perform some kind of analytics, some kind of processing service over the data, then what you will do? If you simply pass the key to the cloud to decrypt that data, the entire provision of performing an encryption will fail. So the traditional encryption system or the traditional security methods provide insufficient security in the cloud environment. Similarly, other thing is that, let's say you are storing a very huge amount of data over the cloud, and then you are performing some hashing function to compute the hash to perform the security of that particular data. So if you are performing such kind of huge computation over your local system, that will, okay. So you are able to see that the traditional security mechanism is not sufficient to perform to provide the security in the cloud environment. Okay. Next, the next is uh, the data loss or data breach are reported even from the reputed cloud service providers. The data loss or the data breach is even reported from the reputed cloud service provider. Reputed means that the name that we are frequently hear, like Amazon, Dropbox, Microsoft, or Google Drive. Okay, so whenever a client hear about a data breach or a cloud outage from a reputed cloud service providers, so they become reluctant to use the cloud computing services. What they think that if these reputed cloud service provider, if a company like Amazon or Google are not able to provide complete security, how other companies are able to provide security to their cloud service users? Okay, so these informations or these news or have very much impact on the entire cloud community. Okay, and it's also create challenge. The reason is the data is replicated over the multiple location around the globe. Okay, so first thing, what Google or Amazon do, whenever you upload your data, they store your data on multiple zones or multiple servers. In this way, the replication happen and they provide the security. Although once thing that I have discussed in the previous slide, that once the replication happens, the issue of synchronization arises. If this issue of synchronization arises, means you have to main the consistent copy of a data over the multiple location. Okay, so the flow of data synchronization will lead to data inconsistency. So what we will do, we will try to replicate the data, and at the same time we will synchronize our data at multiple locations. It is more challenging for a cloud service user to track the appropriateness of the CSP cloud service provider's data operation. And finally, let's say you have told to the cloud service provider to just delete my data because that data is not in my use. That data is not in my use. So it have deleted from 4 location, but it still maintains some copy at the 5th location. And after some time, maybe it is stealing your secret information. Maybe it is stealing your secret information as a part of corporate espionage. That is known as corporate espionage. So these kind of things may happen. Another important point is data storage and transmission. Another point is data storage and transmission. So As an example, you can see that there are two countries. Okay, there are two countries like India and China. Okay, and recently in the news, you about that multiple applications which are hosted in Chinese data centers has been blocked by our government. The reason is that their legal jurisdiction or the country boundary is beyond our country. Means if something happened to the data, if they are analyzing those data set and try to find out the liking and unliking of the users, they can do that. And that is why to protect the individual users or the countrymen, the government has blocked those individual applications. Okay, so these kind of things happen if the data is distributed over multiple locations. So now many of the souvenirs countries what saying to the big multinations, if you are storing customers data or the clients data, store it within the geographical boundary of the country. So whenever a legal issue arises, whenever a government want to scrutinize those data, it will able to do that. If those data is stored on some other location, some other servers in some other country's jurisdiction or geographical location, so it will be the out of bound. No one able to do those. No one able to see those data sets. Okay. Another thing, dynamic nature of cloud makes extremely difficult to designate a specific server or device to be used for inter-border data transmission. Okay, so whenever a data is you uploaded, most of the time it will automatically stored in a zone where you have logged in. Okay, and the many of the time, most of the data that you have uploaded is stored in the data centers, some of the either in the American location or the European or the Asia Pacific locations. Okay, so these kind of thing happen. If the data is not stored in our country, if something happened, let's say that country has banned that it will not allow to access those data, so availability issue arise. Okay, so let's take another example. You have started a company, a startup, okay, and taken a cloud service, and the data center of that cloud service is in a country, and after some time you have hundreds or thousands of user of your services, but all of the data is stored in some some other geographical location, and something happened that your country or that country has banned to access of those data centers. What will happen? It will be affect your entire business. It will impact your entire business. You will lose your data and at the same time your business and the client. So these kind of things happen. That is a challenge in cloud computing, and that is why whenever a client, if you are individual client, that may be not impacting much, but as a company it may be impact business. So that is why companies are very much reluctant. Whenever they sign the SLA document, they make an agreement that data should be stored in the legal boundary or the jurisdiction of the same country where they are operating. Clear to everyone? Okay, guys. Let's.
Sir, I am having one question. Hello.
Yeah. Please,
Sir, as you said, like the companies like even Amazon and Google cannot they are handling the security issues pertaining to cloud.
guys, your voice has been breaking. Okay, just repeat it. Just please repeat it.
Okay. As you said, sir, like the data breaches and data losses are happening regularly. Even the companies like Amazon and Google cannot stop the data breaching. And how these companies, these big MNCs, trust on the cloud in future?
Yeah. No, like they are implementing rigorous provision to avoid any kind of breach. Okay, they implement. It is not like it happens every day, but it happens. Okay, like in 365 days, you see your mail server and Google search is always available. But definitely it happens either for a few minutes or few seconds or few hours. You may experience that mail service is out of bound, or the search is out of bound, or some or other service of Google is out of bound. Even in the SLA provision, when you see, it is not 100% availability. They will provide you 99.999% of availability. Okay, so there is outage, there is breach. It would not be 100% possibility for any person to provide you 100% security. Okay, so whenever a new security breach happen, so that could be a new kind of, even the Google security professionals or the Amazon security professionals have not encountered it till date. That's why they had not removed it. If someone has exploited that vulnerability, and after exploiting that vulnerability, it has steal some or other kind of data, or it has breached the confidentiality, breached the integrity, or breached the availability, at that time it focuses, the security professional has focuses on that vulnerability or that threat and try to fix it. Okay, that could be possible, and that is why we are regularly receive security patches and updates. I hope you get your point. So guys, that's all for this session. We will continue from here in the next session, and we will again meet at 12:15. Thank you everyone for joining.
Right, sir, it is 12:15, right? 1-5?
Yeah, 12:15.
Right, sir, right. Thank you so much.
Thank you.
Sure.